Guys, that's cool. Don't worry about all that. Remember, we are going to use this formula x equal to minus b over 2a when the equation is given in standard form, right? If I say standard form, it's when the equation is given in this form here, y equal to ax squared plus bx plus c, right? So now, let's go ahead and determine our a and b. What is the a value? Here, what is the a value? 1. What's the b value? 6. Negative 6. Good. So if we use x equal to negative b over 2a, it's going to be negative 6 over 2 times 1, which is 6 over 2, which is 3. Right. That's correct. Okay. So now that we have the x coordinate of the vertex, we need to find the y coordinate, which is our h value here. What do we do? What do we do with the x value?
Use the same points. Like you use the same equation, but you just plot in 3 for the x value.
Correct. So we are going back to our given function, then we plug in 3 for x. So to get the y value there, it's just y equal to 3 to the second power minus 6 times 3 plus 5, which is 9 minus 18 plus 5, which I believe is negative 9 plus 5, which is equal to negative 4. So my vertex here is, remember we're looking for the vertex, so the x coordinate is 3 and the y coordinate is 4. We are talking about this here, guys, our x vertex. Remember, always the x coordinate of the vertex is the axis of symmetry, right? So when you are given the x coordinate is h, the vertex will be k. Right. Remember, in today's lesson, we are not focusing about the quadratic function when it's given in vertex form. That's a lesson for tomorrow. So we are just focusing on the standard equation and using this formula. So this formula is very important. Remember, we got it from the quadratic formula. Ron, what is our quadratic formula here?
X equals negative b plus or minus the square root of e to the power of 2 minus 4ac divided by 2a.
All right, so it's supposed to be all over 2a, but in this case I just split it because we need to focus on this part here. So this part here determines the x coordinate of the vertex or the axis of symmetry. So always this is our axis of symmetry, x equal to minus b over 2a. Is it making sense, guys? All right, so now let's go ahead and find the zeros. Please, a misconception here is that most of you, they confuse the factors with zeros. So to solve that problem, find the factors first, express that equation in factor form, then use the zero property rule to determine the zeros. So give me the factors of positive 5 that sum to negative 6.
Positive 5 and negative 1.
It can be positive 5 and negative 1.
Negative 5 and negative 1.
So we have negative 5 and negative 1. Remember, when you multiply these two, when I multiply negative 5 and negative 1, I should get positive 5, which is this one, right? Then, when I sum them up, I should get negative 6, which is the b value here, right? Hence, our zeros are positive 1 or positive 5. Right, so we now have our zeros here. The y-intercept, what do we do to get the y-intercept, guys?
Plug in 0.
Why are we plugging in 0?
Because,
Why are we plugging in 0? Why not 1? Why not 3? Why 0?
Because 0 is that's where the line cross, something like that you said.
Alright, who can sing that right?
Because 0 is the y-intercept.
So,
or cutting or hitting the y-intercept.
Alright, we are almost there. Yes, Ron?
0 is where whenever the y-intercept is hit there, 0 is the point that's on. I don't know. It's on.
Alright, I really appreciate that. I understand what you're talking about, and you are all saying the right thing. You are 95% correct. Okay, so remember the x coordinate of the y-intercept is 0.
Yeah.
When the graph cuts the y-axis, the x value will be 0. Right. Okay, bring your eyes here, guys. Bring your eyes here. This is the graph. Right. Every time when the graph crosses the y-axis, x here is what? Is 0. Is it making sense? That's good. So now we are going to plug in 0. Or if the equation here is given in standard form, your C here is the y-intercept. So my y-intercept is what? 5. So x is 0, y is 5. Or if you want, you can just plug in 0, which is 0 squared minus 6 times 0 plus 5, which is just 5. So that's my y-intercept. So you can either write it in coordinate form, 0, 5, or just say y equal to 5. Y equal to 5 is the y-intercept. All right, so now we are left with 2 key features. But before we talk about, yes, I know I've given you the notes. I need to take your focus here a little bit, right? So when we have, remember, if we have the quadratic graph in it, maybe it's a curve here, or maybe it's a curved parabola, right? So when we have this, what are you noticing about the x values? What are you noticing here about the x value? The x values, I mean.
Increasing and decreasing?
So what it means is that for this graph here, as it continues to go up, it's stretching on both ends. Hence, we need all values. So when we are talking about domain, remember, for domain, we are focusing on x, right? So when you're talking about domain, we always want all values from negative infinity to positive infinity, right? What is another way of expressing this? Okay, you can express that in words. How do you say that? All real numbers, good. So all real numbers, right? Or you can just say that.
Is that R?
Yeah, it's an R with double or whatever, right? It means all real numbers, right? So that's my domain. But we need to focus more now on the range. Remember, we have your turning point. So when your A, this one is when your A is positive. It means the graph keeps going up. We have this value here. What do we call this point, this turning point?
Axis symmetry.
And no, it's a vertex, but is it minimum or maximum?
Minimum.
That's a minimum, meaning to say we don't want values that are less than that. So maybe if it's B here, right? So what it means is that we want all values of y which are greater or equal to B. That will be the range. Range are the y values, right? Domain x. So here, is this the minimum or the maximum point?
Maximum.
That's the maximum. Meaning say we cannot go above that, right? So the values that we want are starting from this point, pointing down, going downwards. So our domain, our range will be y is less than or equal to, maybe that's a B. So y will be less than or equal to B. Or you can say this is from negative, it's from negative infinity to that point here. Or at this point you say we are starting from B, but it's open ending, so it's approaching positive infinity. Right, so now let's come back to our question. So coming back to our question here, we have, remember our A here, our A is positive, right? So since A is positive, do we have a minimum or a maximum point?
Maximum.
We cannot have a maximum point because A is positive, the graph will be like that. It opens up. So when the graph opens up, we have a
Minimum.
And remember that minimum is the y coordinate of the vertex we found before. And what is that y coordinate of the vertex? You have it.
-4.
It's -4. So now let's start by identifying the domain. What will be the domain here?
3.
No. Remember, if it's quadratic, it's always all real numbers, right? Or you can say from negative infinity to infinity. That's a quadratic graph, unless it's restricted. But if it's not, you want all values of x, because if you plug in any value, you're going to get a y value. Is it making sense? Right. Let's talk about the range. Just because a is greater than 0, we have a minimum point which is -4, and we cannot go below -4. So our domain, our range will be y is greater or equal to -4, or you can write it in this form. It's from -4, you put a bracket here, then you put a parenthesis there. Or you can say it's stretching from -4 less or equal to y, strictly less than infinity, because it's open-ending, it keeps going. Right, so that's how we determine the range. How do you feel about these guys? How do
Good,
you feel?
Mr. T.
With
I
more
feel
practice,
good.
it will get
I mean,
better, right?
more practice on the domain part.
Yeah.
The domain.
That's very true. Even my Math students, they struggle with domain and range. So always revisit the notes. Remember, we did that in our previous unit. Yes, Ron? Okay, good. You can go. All right.